Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Brosman and this is our members Muhammad Ashdan, Muhammad Syafiq and Nur Syaira. Today our group want to present a mini project for the subject pilot plan of version 2. So our parts is explain process flow of the plant. For the process flow part of the plant, we took the production plant from the company Mukah called Fire Power Station Sarawak, Malaysia. In short, this company, it is a steam turbine power plant. The power plant runs on dual fuel. The primary fuel being used to power to plant is coal. In case of shortage of coal, the plant can also run on distilled fuel oil. The fuel is procured from Mukah Balingan coal field. So the coal fire project consists of two steam turbines, each with 135 nameplate capacity. So for the plant, coal fire plants produce electricity by burning coal in a boiler to produce steam. The steam produced under tremendous pressure flows into a turbine which spins a generator to create electricity. The steam is then cooled, condensate back into water and return to the boiler to start the process over. So that's all from me.
So next, for the function, I will explain four important units in the plant. So firstly, steam plant, or we call it as steam generator or boiler, that has in the process flow diagram the boiler containing water, then the heat that generated in the furnace will utilize the water and convert into steam. It converts the chemical energy such as coal, oil and gas into mechanical or electrical energy. For reaction turbine or engine turbine, this is the main power that will use the heat that come from the steam and use it to perform work or run the plant. Next, the refrigeration cycle. This cycle used to remove heat from a specific area and maintain the temperature lower than the atmospheric temperature to cool down the products. And lastly, the compressor. Compressor is one of the important parts in the refrigeration cycle, which will increase the temperature and the pressure of the gas in the process called compression process.
There are three important components in thermal steam plant, which is coal, boiler and turbine. Firstly, the supply coil will be burned in the boiler to produce steam. The steam produced we send to the turbine in order to rotate the shaft of the turbine to produce electricity from the conversion of potential energy to kinetic energy. In this coal thermal steam plant also has refrigeration cycle. That is, the input is work, the output is either cooling or heating, and the equipment involves a condenser and boiler. The process is some amount of the steam that left from the turbine will go to the condenser to convert it from the vapor to liquid as it gets cool. Then it is pumped back to the equalizer to be heated and into the boiler for repetition of the cycle. Next, we have reaction turbine. In reaction turbine, there are three equipment involved. That is boiler, turbine and generator. The steam produced by the boiler is sent to the separator and get heated at high temperature to become only steam, not wet steam. Then the steam is sent to the turbine as the steam will strike the turbine shaft in order to make it rotate, while the turbine is attached to generator to generate electricity as I mentioned before. That is the conversion of energy from the potential energy to kinetic energy. Lastly is compressor. The equipment involved is compressor itself, and it has two types of compressed air in the thermal power plant, which are external air and service air. External air is for operation of pneumatic, but the service air for purging and cleaning of ash from the coal burn. In this coal thermal steam plant, we is more prefer using boiler than evaporator, because in large industry we need to burn more coil, and boiler is the best equipment we use, because the size of boiler itself is a bit more bigger than the evaporator, and the output is more bigger than evaporator. So in large industry, we prefer boiler than evaporator.
For my part, I will suggest a non-destructive testing method that is applicable to the chosen plant. So first of all, let me explain a little bit about non-destructive testing, or in acronym form, NDT. Non-destructive testing for power generation are crucial to public safety, safety of your team, and also to the business flow. The structural, mechanical, and electrical integrity of the power plant is guaranteed by non-destructive testing. And for power production, non-destructive testing is very essential for spotting probable flaws and structural flaws to prevent unnecessary downtime or future capability loss. So to proceed, there are 3 non-destructive methods that I chose for this specific plant. For the first one is electromagnetic testing, laser testing, and also leak testing. So for electromagnetic testing, when conducting electromagnetic testing, a conductive part is passed through an electric current or magnetic field. Remote field testing, which is one of the 3 electromagnetic testing methods, is frequently used to evaluate pipes. It is useful in our situation because it can assess the condition of the thermal plant's pipes. And then for laser testing, it is divided into 3 methods, which is holographic testing, laser profilometry, and laser chirography testing. This method makes use of a laser to find surface changes in materials that have been stressed by heat, pressure, or vibration. Defects are then visible by comparison to an undamaged reference sample. Laser profilometry detects surface changes by a 3D image created from the surface topography and a high-speed rotating laser light source to identify corrosion, pitting, erosion, and also cracks. Before the surface is pressured and a new image is generated, laser chirography employs laser light to create an image to find out whether there are any flaws. These photographs are put side by side to compare.